So Mike and I thought it would be really fun to do this in public, which is why we're kind of streaming this. So on the Effect website, we use a tool called Contentlayer, which was built by the amazing Johannes Schickling, a fantastic purveyor of developer tools. But unfortunately, that project is no longer maintained, and it is built with Effect, but it's built with a much older version of the project. And so that, carries with it the lack of all of the optimizations that we've made over probably like the last year and a half or so since the project was developed. And, it's there are some improvements that we think can be made on top of the existing software to make it function better. We're on the website, we have a lot of content and we're noticing like slightly long build times. And so we wanted to see if we could potentially take content layer and reimagine it for our own purposes, kind of make things maybe a little bit more performant, parallelized, and potentially improve the user experience. Yeah, that's kind of what we were thinking we would do. We thought it'd be fun to do this in public. We thought it'd be fun to stream it, just so everybody can sort of see, I don't know, the approach that Mike and I might take to developing a semi greenfield project, even though it's not really greenfield. So yeah, I don't know if there's anything you want to add, Mike.
No, I should say that none of this is scripted. So this is not going to be a kind of presentation where we go through a single thing and so on and so forth, but we're basically exploring ourselves. So it might take one session, might take two sessions, might take 150 sessions, doesn't really matter. I think the goal would be to optimize our own build pipeline to build content efficiently. And if we get to publish something available for other people, that's good. Otherwise, we will enjoy the benefits our own. But yeah, let's start.
Yeah, let me try to share my screen. Um, yeah, so this is just an empty project. I essentially took the effect monorepo, cloned it to a separate directory, and emptied it out and removed all the Git history, and just set up like a single like core package in here, just to give Mike and I a place to kind of hack. And yeah, so that's what we have going on here. But maybe it would be good for us also to kind of take a look at how content layer currently functions, what it is, the things that we like about it, the things that we don't, and some of the like user experience that we want to carry over from the existing package, and like maybe take it from there. So I can open up. Let's open up the website and we'll check out the main branch. And then also maybe what we'll do is open up the website. Yeah, so Constant Layer, like we said, is a really excellent tool. It's basically as it says here, a content SDK that performs validation on your static assets, and then also transforms those static assets into JSON data that you can then import into your application. So the existing content layer project is it kind of has different like sources that you can use for your content. I think Mike and I are probably just going to focus on like the local file system source for the moment. But the experience that you get when using content layer is something like this. So um, you would first define like a content layer configuration file, and the Effect website's content layer configuration is obviously quite complex. But if we kind of boil it down to the relevant pieces, um, in existing content layer, you define a source for your content. So, like, where does your content exists? For the Effect website, all of our content lists exists under this content directory. Um, any directories to exclude from like the search path, the document types, which we'll take a look at in a second, and then you can provide some other options, but we're not really going to get into this for the moment. Things that like you can add plugins to your like processing MDX and whatever, but not going to really focus on this for the moment. What I think it would be cool to focus on for now is how document types are defined and how that translates into processing your content via these document types. So maybe we could take a look first at the docs page. So with content layer, to define a document, you use this define document type helper. You give your document a name, a file path pattern, tell it the content type, and this file path pattern is relative to the content directory that you have in the parent config. You also give fields to your documents, and this field is kind of like a little built-in type-safe DSL for describing the fields that should be present in your data. So, for example, for all of our Effect website docs page documents, um, for all of our documents, we have title, we have a nav title, we have excerpt, we have whether or not it's collapsible, et cetera, et cetera, et cetera. And then you can also define computed fields, which follow a kind of similar spec where you define the type, you might have a description. But the difference with the computed field is you have the ability to actually resolve the data that that field represents dynamically based on information you're getting from the page itself. So you can, take the fields that were processed and maybe derive some computed fields from it. We do this for a number of different things on the website, headings, sections, et cetera, et cetera, et cetera. Um, and so if we look at like how this maps to our content, so now I'll also open up like maybe an example docs page. We'll just look at the introduction. So on the Effect website, the vast majority of our documentation, our blog posts, etc., are all written in MDX, but you can write in Markdown as well. Um, and for Markdown or MDX, the fields, so to speak, are being processed from the front matter. So if we look at this title here, Welcome to Effect, this would be processed by this field here in the document definition. So the idea is that the document that you define kind of describes both the content of that document as well as any like specific structured fields that should be exposed. So we have a bunch of different stuff here, and this would be validated by content layer, um, like while it's being built, essentially. And you get like errors reported if what you've defined here doesn't match what you've specified in the spec for your document. Um, and then once it's built, once you've actually like built your document, you get this little content layer directory, which has some stuff in it. The I think relevant to like the actual generated content, we can look in like this generated folder. And for the docs page, obviously we have a lot more stuff in here because we have a lot more docs page documents. But um, if we look at the thing that content layer generated that corresponds to this MDX file, that would be this one. And you can see we basically get like like a static JSON representation of the document, which has both the fields that we've defined, which have now been like validated by content layer and it's spitting it out in JSON. And then we also have the body of the document. So we get access to things like the actual raw content that's being processed through like an MDX processor. Um, and then there's a whole bunch of other things in here as well, um, that you get access to that are kind of more relevant to the um, source that you use. So if we look again at the very top level config for content layer, we're using the source files content layer plugin, which means that all of our documents are coming from the local file system. Um, and so again, I think like for our reimagining, we're going to focus probably just on like a file system source. But I think the goal is to still have the ability to have different sources maybe in the future. So we'll kind of try to keep that in mind. But our focus will be making this work well. Um, Yeah, so, like, with the file system source, we get things like, the file path, file directory, content type, etc. And all of this is statically defined in JSON, so it can be easily imported. And Content Layer also generates some index files here, which essentially, if we look at how this generated index corresponds to this one, um, we get a generated index file in here that imports all of our documents as JSON, like kind of asserting that the type is JSON here. And then in the root index, we get access to all the docs pages, all our blog pages. You're kind of getting a sneak peek of potentially tutorials coming up in the future. But the point here is that we get access to all of these statically generated documents as code, which is nice because then we can use it in, for example, like our React components to then, display the user interface. So I'm not going to go over like exactly how we do all of that because the website is open source. But if we look at maybe the docs layout, so you can see here, we can import directly from content layer generated because content layer also generates this package JSON here that allows us to do this kind of thing. Um, and um, trying to find where we use it. Yeah, so you could basically do things like iterating through all the docs pages, f- you know, basically operating on your documents programmatically at that point. So your local file system becomes your CMS and content layer becomes the kind of processor for those documents. But there are a couple after having used content layer for a little bit, um, on the website. I mean, there are a couple of pain points that like I've come across, just from like a UX perspective, and I think that these were on the roadmap for content layer anyways. But now, we have the opportunity to kind of like reimagine this. But if we close down all of this, and again look at the root, like kind of make source function that we get from the plugin, one of the things that I kind of um, thought was a missed opportunity is the ability to, if we look at this right now, the make source function assumes that all of our content is coming from the local file system for all of these documents. And we only have the ability to define one source here, that I know of. Maybe Johannes can correct me if I'm wrong if he's watching this at some point in the future. But this is kind of like, I feel like it's a missed opportunity. There may be documents you do want to fetch from the local file system, but there also may be documents that you want to fetch from, like, I don't know, a CMS or I don't know, some sort of blob storage or whatever. And so it would be kind of cool if the documents themselves had their own source, right? So the source was embedded into the document instead of the documents being embedded into the source. This way, when you're fetching content for all of these documents and processing it, you can define whatever source you want for a given document. And another thing that I thought was kind of like um, it's not a missed opportunity because I don't know if like effect schema existed back then,
No,
but
it didn't.
but, but now that we have effect schema, um, we don't really
Rather, it
need
did, but it was a very, very
right.
early thing, and obviously you don't want to keep updating your document definitions every new release of schema. Now it's fairly stable. So
Right. I mean, uh, now that we have effect schema, we don't really need this little type safe DSL that content layer provides. Yes, it is nice, but it's limited because we can't really do, unless we make a field computed, we can't really do any additional validation um, at validation time on these fields. Um, and then the other thing that some folks may have noticed is if you define, like, for example, like a JSON data type here, if we look at the actual generated type for this in content layer, where is it? Types. Yeah, here. So this JSON type doesn't exist. So when you actually go through and like, I don't know, try to use headings, you'll be left with an any, just kind of like not desirable. Like in like an ideal world, we would be able to um really like spec this out a little bit better. Now that we have effect schema, we can do that. And we'll get all of like the benefits of effect schema. So I think like two of my like wish list items when we're kind of reimagining content layer are to have more pluggable sources. Again, like for now, we'll just be focused on file system. But if we build this in such a way that the source is attached to the document instead of the other way around, I think it would easily lend itself to other types of sources. And um, the spec for the fields of a document, I think, should be like 100% defined by effect schema. And then the computed fields also should be effectful. So so, like, instead of being, because if you look at the resolve type here, this gets a computed field resolver, which
Well, I mean, there's a clear difference. Content layer was targeting non-effect user. We
right.
couldn't care less about non-effect users. So
I mean, if we were building this as, like, a content layer V2 or whatever, of course, we
yeah,
would.
we would.
I was actually chatting with Johannes at one point in time about doing that, like, just kind of thinking about, like, a way to do this, and the thought I had had was build the effect version as, like, the underneath. If people wanted to use it, great, but then build, like, slight, like,
A
wrapper
higher
layer
level
on top.
API.
Right, that exposes the old type safe DSL and whatever. But since we're doing this for ourselves and we're being selfish, we're gonna do this in a very effect way. Um, and then I think the last wish list item I have is, and I think Mike mentioned this when he, told me he wanted to do this, was making this as like concurrent as possible, like be really leveraging as much as we can, like the
Yeah, this
effect.
should be deeply parallel. Not even
Yeah,
concurrent, actually deeply parallel.
yeah.
Because
So
we are processing multiple files, and at the moment they are almost processed sequentially, and this transformations happen on source. As we saw before, we could use remark plugins and so on and so forth, and especially for us where we use Shiki 2 slash, and we would like to use the new version of Shiki which embeds 2 slash. uh, we have basically we are compiling every single snippet in a sequential manner, which means generating the documents take a long time, and we're already hitting a point where a cached build takes about 3 minutes, 2 3 minutes. A non-cached build can get up to 10 minutes, and we can actually not no longer update the renderer of Shiki, because otherwise we use more than 10 minutes and Vercel kicks us because we can't build for longer than 10 minutes.
yeah,
Max, apologies, you have the webcam which sometimes um, I don't know, loses focus.
I know.
No idea
I
why.
and I need to upgrade my webcam. So for anybody who's watching this and sees me going in and out of focus, I'm sorry. I promise I'll get a new webcam for the next time. that's that's fine. I could use my Mac, but and or my phone, but I don't have a way to like actually hold it like in the right place. So for today, I apologize. Like I'll be going in and out of focus, but next time I'll have everything much better.
I
The webcam only loses focus. Thanks, Sebastian. Um, so yeah, and then I'll mention one other feature of Content Layer. So all that being said, Content Layer is a fantastic piece of software. It made building the website like much simpler for us because we didn't really have to worry about uh, anything related to the content. We just wrote MDX and let Content Layer take care of generating the actual like code for us. So like all of the kind of wish list and like missed opportunity stuff aside, fantastic piece of software, and Johanna should be given like big kudos for working on this. The other thing I'll mention really quick in this content layer directory, you'll notice like a .cache directory. So content layer maintains a versioned cache for documents. So, like when you're developing locally, this doesn't really help you very much in like CI unless you push the cache somewhere. But when you're developing locally, as long as you haven't upgraded your version of Content Layer, you do get like cached assets for your documents. And um, when I was thinking about like ways that we could reimagine this, I had talked with Mike about potentially making the cache also pluggable, so you could have an external cache, or the file system could still be your cache, whatever. But um, the other thing that you'll notice in here is this kind of cache items map embeds every single document in here. So it's like a huge file. I think it's every single document. I could be wrong. Yeah. So like all of the documents and all of their cached items and stuff like that. We have now in effect, which didn't exist back then. So like, you know, but we have things like the key value store for effect, which could easily be used as like a local file system cache, where every document gets its own separate file and has its own cache entry, et cetera, et cetera. So, yeah, there's just like there's a lot of ideas that we had floating around, so we thought this would be a good time to, um, act on those ideas and potentially do this. So, um, anyways, that's a little bit about Content Layer, a little bit about the history, how it works, etc. But maybe we can start like actually digging into some code now. Okay, so the traditional foo export. Um, so yeah, Mike and I were chatting just for a few minutes before we started the stream, and we thought like a good place to start, or maybe like a good place to like start thinking about this, is like what do we like about the existing user experience, that we want to kind of preserve. And one of the things I really like about Content Layer is that the config file is just like a plain TypeScript file that you can, do things to manipulate your document. You can define your document in code, and then that file gets compiled and used by um, the actual like software to do all of the document generation and caching and validation, etc. So like I think preserving the content layer as just like, or preserving the main config file as a TypeScript file that you can import things into and define in code, I think is desirable. And yeah, I think like if we start thinking from there, um, that would be good. Do you agree, Mike? You like the fact that like content layer has like a TS config file and everything like that. This way it's just plain TypeScript you write, and it's really all.
Yeah, of course, I don't want to write on type JSON.
Or we could just like embed everything into YAML. It's just nothing like writing YAML code in your
Kubernetes style.
um yeah, plus we want all of like the excellent features of effect schema and effect and whatever, and so doing this in code in TypeScript makes a lot of sense from that perspective as well. Um okay, so maybe like a good place for us to get started would be to start reimagining just like the document type and what that looks like. Um and I've thought a little bit about this before. So, you know, Mike and I can sort of like hash this out. But in an ideal world, I thought like the document type itself could be generic on a few different fields. Um, no pun intended, because the first generic uh, I thought could be like the fields of the document, meaning like if we think back to the like um, docs page config that I showed you before, kind of like the front matter fields. Oops. So like, we have our wow, why can't I type today? We have like our title, which is, welcome to effect, etc. And so like I think being able to see like when you hover a document, so like if we were to like create a docs page or something like that, which is a document itself, being able to like hover this and see like the fields that one would expect to be in that document, and like the type of those, that like the actual type that one would expect, I think is desirable. um I also think it would be kind of interesting if we could keep the computed field type in here, whether we merge these two together or not. It would be interesting also to be able to, like, as a user, when I'm like writing my document, writing the computed fields, it would be kind of interesting to be able to hover and see, like, these are the fields and these are the computed fields of the document. Um, it might be possible for us to like merge these together. It might not be, but for now we can keep them separate and sort of think about it. Um, and yeah, so maybe we can start there. Let's think about, like, if we were to create like a post, keep things simple, and uh, make, which takes some field and returns a document, which we don't know what's going in here yet. But the idea that I have is kind of like, um, again, just kind of like giving everybody an idea of what I was thinking. Um, so this would be like a post. It could have a description, which is like the posts. We could. So I think having like the source here also. So like if we have like a, I don't know, um, function file system. Again, this is my ideal API. Uh, just leave it as any for now. But maybe like, I don't know, pass in a glob of like content, uh, posts, right? Like, give me all the posts for this particular document. What else? What else? What else? What else? Fields, obviously. Fields, right? And for fields, we're gonna.
Basically, a straight schema.
Yep. I I don't know, like, if it makes more sense. And I have to install this. So give me one sec. Add. So I don't know if it makes sense for fields to be a straight schema or for us to always enforce that it be like a struct in the like, because I don't know if it really, if you'd ever have a field that's like this, right? So like you
Yeah,
may,
probably not.
so I kind of think like, in schema there's this type, um, schema dot struct dot fields, which represents kind of like what I'm talking about, where you have like essentially, we can actually go look at the type. It's essentially just like a mapped type of, or a type with an index signature of a property key and then maps to some schema, right? So I think this is kind of what we want, maybe. Well, we can go with it and sort of think about it, but maybe we have a title and maybe we say schema dot non-empty. I think this is getting changed to non-empty string in the next version. Um, but like the idea here is that like your fields are always a struct. They're always going to be the like fields of a struct, and like then you have the ability to define your fields um with schema itself, which is really nice because you can do like filters, transformations, you can do validation, things like that. All the goodies that you get with schema, um, you would essentially have, um, like, on your document already.
And we
Um,
also have to think about how to define like computed fields and stuff like that.
Yeah, I mean, in an ideal world, I think a computed field would look something like if we pretend that we think we can put it on here, which I think from a TypeScript perspective, this is not going to work. But if we say maybe like we want a slug computed field, right? We still have a name, which could be the slug or something. Or maybe this name is actually derived from the key in this case. Could have a description, which is like the title slug. Um, I think, a resolve function, which returns some effect, right? And I think it would be really nice if, similar to how a content layer already works, we get metadata. Like when you define a computed field in content layer currently, you get access to the fields of your document, right? So you get access to the fields, the existing fields, these fields in your document. Um, and you also get access to in here, like the object that's passed to, oops, that's passed to the resolve function. Um, you get all your like fields and stuff, but you also get metadata related to the document source. So if we recall back to the stuff I was showing you before from Contentlayer, you get access to things like the file system path that the document was found at. You get access to the file name, et cetera, et cetera. So I think in my ideal API, because I've been thinking about this for a little bit, you'd also have something like, maybe meta or source meta here, where, and let's import an effect.
On the other side, this could also be quite literally a schema transformation.
It could be, yeah. Right, where we would do like maybe like fields dot title. And again, we don't have to go this route, but if we just like think about what this would look like. Um, this could be a schema transformation. I don't, and
No,
then
I mean, if fields, instead of being just a structure, is a schema, then we could build some higher order functions on top of a schema, where we could say like the schema.pipe add computed field, and do it on a step by step basis, so we get progressively access to like the previous type, and so on and so forth. That's just an idea.
yeah, that would be kind of cool. The idea I had related to schema for computed fields, and we can again go whichever way. I don't really care, but was to pass in the schema that you expect. Schema dot non-empty, where this schema describes like the expected return type from the resolve function, so that we have the ability to validate. But I kind of like the idea that you had, Mike, where like if fields isn't a schema already, maybe we could use schema transformation somehow to get rid of the need to do this. Um, but anyways, if we start thinking about this, maybe we like to make things slightly simpler for ourselves for the moment. We can think about just this, right? So if a document has a name and it also has a possible description, I think in the end it would be easier for us to work with the resolve document type to have an option of a string for description. Um, for now, we can just say that a source is anything, because, or we can even do now, right? Um, now, um, if we start to think about like how make would work, because let's actually start thinking about how make might work, because um, I'm trying to think about like what the options would look like, right? So if we so fields extends schema.struct fields, and we say that options, there can be a name, read only description, which will just take an optional argument, optional description, read only source. Now, um, when we look at post here, this is not really the user experience I want. From my perspective, this should be title string, right? I think one way we could potentially do that is we could make, because if we think about how content layer is going to handle these documents, like in reality, like when the document gets imported into the engine, we can call it like the core engine of content layer, it all the type information that we have like in the config file is going to be lost. So from the config file perspective, we want fields to be like the simplified, like, title string, et cetera, like show you the actual like destination type of that schema, the type of the schema, not the encoded type, but or the like struct type. We want this to be like the destination type. So what we could do is we could do here, and then instead of because again, like when this document gets imported into content layer, and we'll have to probably add like some variance or something so that this isn't just a dangling type. But when we import this document into the engine, the type information about the fields is gone. We don't have any of that information anymore. We just have the schema itself. So we don't really need this to be typed, but we want this to be typed. What do you think? Because now, like if we look at post, we get like the actual like fields themselves, like in the destination type. When the schema is decoded, or when the document is decoded, like this is what you'll be left with in terms of fields.
Yeah, I mean, we have to decide because with schema there's different things we could track. We could even track the input type, but I don't think that would be relevant. If you want the types clean, this is probably the best way,
All right,
and
so
just tracking the output.
I am going to need your help with probably the variance annotations for this, but let's create a prototype type. We do this so for those of you who may be less familiar with like the effect library and like the type shenanigans we do inside the library to make things nice on the outside. Um, we do this pretty frequently inside the library. We kind of define like prototypes or variance types for our data types, both to one make them like kind of unique, and also to define methods that maybe we want present on every um, one of these types, and also to define variance. So let's do, oops, const type ID unique symbol symbol for add effect. Let's just, we've named this project content for the moment. This is like very much subject to change. Oops, type type ID. Um, so let's do uh, so the prototype itself will take fields. This thing will take fields. This thing will take fields. And I guess this would be invariant, Mike?
I think it's safe to make invariant at first and eventually make it covariant, contravariant, but I do think it's going to be invariant at the end.
Maybe this is a good opportunity to explain invariance. Oops.
Mm, Probably not.
And, uh, the simple version extends.
I think the
Doc.
the simple version, look, it's pretty much how TypeScript handles it. There's two type modifiers. It's called in and out. If a generic is used both in an input and in an output, you have to say that it is used both in an input and in an output. And in this case, the type would be invariant. If instead it's only used in an output, it's going to be covariant. If it's only used as an input, it's going to be contravariant. Now, those are odd and weird names that are not really supposed to mean anything unless you know you know the meanings in type assignability in terms of like categorical thinking. Uh, but I don't think should it should matter here. And also, by the way, Max, you are using methods which are bivariant by default.
God. Okay, wait.
So that's that's not how it's supposed to be used.
See, this is why Mike's on the call. Uh, just to give people an example, I mean, I don't, this is my mental model, may not be 100% correct.
It is exactly correct. And if you think about it, if we have only like the covariant thing, if I have a document of some type which is like I don't know, let's pretend fields can be a string for the sake of simplicity. If I have a document of a string and I have a document of a string or number, the one that the document of a string could be used in place of a document of string or number, because a function that always returns a string is also a function that always returns a string or a number. It's just more strict, just returns
Right,
one of the two instead of both. That's not true if I have a function that takes this as an input, uh, because then a function that takes a number of a string or a function that takes a string, I cannot assign a function that only takes a string to something that requires a function that takes as arguments string or number. Because if that is used at any point in time, it could be called with a number, and of course my implementation only accepts a string. So this is assignability. And if the generic appears both in an input and an output, then there's no widening possible. Uh, a widening in the input sense would be instead of an end, which is different from the or. Now, if you think in terms of an end, the example with string or number no longer makes any sense, but it could be that I take a record with, I don't know, A to be number and a record of B to be number. If I have a function that requires as an input a structure with only A, I can call it with A and B. Doesn't
right.
I'm passing more than what's needed, not less. So this is the widening on the input side and the widening on the output side. If the type is used both in an input and in an output, it cannot be widened at all, which is what invariance means.
Cool.
Apologies for the tangent, but
No,
Maxwell
that's
requested it.
I requested it, so it's my fault. But thank you. Yeah, that's I think that's a good way to think about it. Oops. Wow, Vim. Um, I'm gonna delete these. But the other benefit like that we get from doing this is like the phantom field doesn't give us issues. But I mean, there's other ways to get around that. But I think the main benefit we get is that like kind of like assignability. And then having the type ID on here makes the document type like unique, so to speak. Like when we create these, a structure that has these properties, but no type ID would not be assignable to a document. So that's kind of like why we oftentimes add these type IDs to make the types unique. Um, one last thing. Actually, I'm not going to add it yet. I was thinking I might make this a pipeable thing, but what the hell? Let's just add it. Uh, pipeable. What's going on with my auto imports? Um, we also have like these type helpers within Effect that are basically just ways to shorthand define these functions so it looks less messy. So if you see me using like these invariant, or there's also covariant and contravariant in the Effect types module, that's what it is. Pipe. Hello. Oh, cool. So now all that, just so that we can now when we hover a document see the actual types, and we can add a few more. Maybe I don't know. Um, let's actually say that there's also an author, right? And we have a. I think this will probably illustrate the point a little bit better. I don't know. So now when we hover post, we can actually do simplify. Yeah. So now when we hover a document, we get like the type that we're going to be operating with, like um, when we actually generate these documents, like this is the type of the fields that you'd have access to, which I think is also useful because the other thing that content layer does, which I think I like completely forgot to highlight, we saw it like when I went through the index.d.ts, like the TypeScript declaration file, but it actually generates types for your documents as well, so that like when you import all blog posts, all docs pages, whatever, it's typed with the fields that you have access to, in addition to some like metadata. So these would kind of be the fields that you'd have access to on the output document type, as well as like the generated document once the engine processes everything. Um, so I'm gonna keep ignoring computed fields for a minute, because the other thing. Well, no, let's not ignore computed fields. Let's see. Um, so I think from my perspective, we have solved at least this piece. Um, I'm not 100% sure whether we're going to be able to like merge the computed fields into these fields, so we only have one set of fields. We can sort of talk about that as we go. But from a type perspective, I really don't actually know. Like if we were to define computed fields uh, here, I don't really know what this would look like. I think it would be what we want is um, this, right? Maybe. And I don't know how you feel about this, Mike. Maybe we can go with this for now and then
I
always
don't think
swap.
this will ever work TypeScript wise.
Yeah, I don't think so either. That's why I'm saying that
So
this
it's
doesn't.
completely it's not very useful to go on a road we already know it's not going to work.
Okay, so let's do this instead. Let's make let's take this and put it down here and think about this for a second. So we want to take a document, we want to add a computed field to it. So we could make a method on the
Well,
document.
first question I would ask also is what do we need in the computed field? Let's say we add two computed fields. Are they added in a sequential manner so that when we add the second one, the first one is already present? Or are they added in parallel so that they don't know about each other? Um,
My perspective would be that the only like static information that you have available to you with computed fields, like to make things like as fast as possible, I think you should only. I mean, we could debate this, but I think like they should be done in parallel so that you only have the fields and the source meta available to you to compute the field. So because adding them sequentially, like if we have like a ton of computed fields, that kind of like makes it extremely difficult to do obviously the concurrent side of things, right? Like if we did them
Well,
in
I mean, the computed fields should not have side effects in general, so doesn't really matter if you do it in parallel or in sequence.
yeah.
Like even if you have all effects, it's actually gonna be more performant if you do them in sequence, unless you are actually having any IO that you can parallelize. So I think it's rather
Well,
a
I
matter of
was I was thinking like you could, so again, we can debate this, but we could give users in this resolve method, we could give them we can't I don't it's not possible from my perspective to give them access to unlimited context because there's no way to resolve that, but uh we could give them access to the context that we know is going to be present at this time. For example, when we actually run the document through the engine, I mean, we know we're going to need file system, we know we're going to need path, we know we're going to need like pretty much a lot of the platform specific stuff. So we could allow this effect access to pieces of the context that we know we're going to have that we can provide, like the file system, for example. So the user could, in theory, do I/O, and that actually replicates kind of the behavior of Contentlayer currently, where that resolve function is just something that resolves to a promise. So the user could technically do whatever they want.
yeah, but on the other hand, if we think about an API where you can do progressively, like if we think this about something chainable, you say dot add fields, add computed fields. You could specify add computed fields and specify 5 of those, which will run in parallel, and then do another add computed fields that has access to the previous one. So you kind of control what you want to do. Because I don't know, I do see usages for like I want to compute the slug, then I want to compute something else which depends on the slug.
Yeah,
Could be would be quite tedious to have to recompute the slug because you know being an effect doesn't mean that it actually performs something async.
right.
Even if it performs IO, but it is synchronous IO, there's no opportunity to do anything parallel. I think the parallelism that we want is more at the document level. We want to process two documents in independent threads, not really
Okay.
this level. But those just like pretty much
So
opinions.
no, I think that makes sense. So maybe like even if we say, okay, fine, like the computed fields are processed sequentially, um, like every time you add a computed field, it, like with maybe like even within the fields, we could, like let's try it your way. Let's try it your way. I think that probably gives people like the most um like flexibility. Um so um maybe we could do this one of two ways. We could make add computed field a pipeable like type of situation, or we could just add a method on the document, um, which returns like a new document. Um, let's see how like a method would feel. Right. So if we do the title slug schema dot non-empty and resolve gets access to the fields. Whoops. And the meta. And keep calling this source meta. And again, this is obviously not how you would compute a slug, but um, I don't know. I think this isn't too bad. One thing to consider is on the type level, we might want to like prevent collisions between computed fields and fields, etc. But I think this is pretty good. Like, I don't know. Maybe this is the better slug. and fields.slug dot slice. I don't know. Like,
Well, this allows to add only one computed field per.
yeah, like we could do it this way. We could make it take an array maybe. I'm just not exactly sure from the array approach, like on a type level, how we would do that. But like this would be like the most if we say that everything's going to be done sequentially, then like this would be like the most. We could pass an array. I'm just saying, like from a type level, um, this might be easier. I don't know.
I don't know. I would simply have like this take a variadic number of arguments, add computed, and then a variadic number of things, so that you can either do one or.
Something like this.
Something along those lines. So you have both the benefit of parallelism if you want, and sequentiality if you want. Like this in the second one, you will not see the slug. So those
Right.
two can run in parallel. But if you then do another add computed fields, then you see the previous. I don't know if this can work or not, but
Let's find out. Let's find
let's
out.
find out.
Let's call this something else. Foo. Okay. So I
Does
think,
the computed field always have a name for sure?
yeah, I think it has to.
Then I could
Um,
simply take an object of name and spec instead of, might look easier.
like
Yes, there we go.
let's see.
One more parenthesis at the end.
There. Yeah, this is cool. All right, let's try. So maybe we can either do it on the document or on the prototype. Maybe we'll just do it on the document. Let's do it on the prototype. Add computed fields, right? And this is going to be a record of a string and any, which we can fix up in a second. Um, so add computed fields. No, this is going to be, yeah, a record of string or any, and maybe we do like inside here. So a computed field itself is going to have a name. It's going to have a potentially a description, like just like the document. Uh, description. Did I spell that? Yeah.
I think there's also a mistake in line 31.
Yeah.
If that's a method.
I haven't done anything here yet. I will make this not a method though. schema dot any schema except for never. I guess any. For now, we'll make meta any because we haven't even done anything with the document source yet. Uh, and for now, so let's take in fields here. The idea here would be that this effect is the return type is restricted to like the return type of the schema. Something like this. I know this isn't necessarily exactly what we want, but the idea here would be that like the effect returned by resolve is restricted to the schema's return type. So let's just go with this for a second. Um, so so this is going to be a record of string to like really like any computed field. This, I don't think this is going to work. Maybe we can call this like resolver schema. Extends. Um, okay. So let's do.
I wonder if to do this progressive enhancement, shouldn't actually we use the this type?
Well, we eventually we could, but and that's what I think what I had before. But the you mean this type here, right?
Uh,
Like this schema, is that what you were saying before?
Yeah.
So eventually we want to hoist the like the type of this thing, right? Like this. This should eventually show up in our type signature. It should eventually show up in our document like type signature, right? Um,
Well, I mean, shouldn't the type track in the document be the final type? What do we care if a field is computed or not?
well, yeah, in an ideal world, like everything is just in one type, like you
Yeah.
say. So like in an ideal world, there's no separate type here. This is just like fields.
Yeah.
And then internally to the document, we would have like a read only of computed fields, which is probably going to be like a read only array of something. Computed field. Right. Oh,
Or it's just part of the field's definition.
the only thing. Well, yeah, we could because what are we taking here? We're taking a name. Yeah, we could potentially like transform this into a schema and attach it to the fields. Um,
Yeah, because I think we shouldn't confuse the like the structure of the document with what we want to specify as an input, because the input we're just gonna specify via make function anyway.
Right.
So the final representation might be different from what we manually specify. Yeah.
So let's try your way then. Let's try schema.schema.any, I guess. Something like this.
Probably, or not even. Mm, the result. I'm more thinking about the type of the add computed fields.
Okay, let's focus here for a second then.
Now this could be fine because you have access to fields here already.
Yeah.
So yeah, you're using a generic prototype, which is fine. Okay, then continue your way, and we see. I mean, if
Yeah.
we can get this without, no pun intended, using this, it's better.
Yeah,
Using this type on a method.
I think I mean what I was thinking is uh without using if we did this without using this, just hear me out for a sec. This would be like resolver schema, right? Which extends schema.schema.any. And then this probably gonna have to do some shenanigans, but this will return a document. And in this document, we essentially want to do the equivalent of like fields and computed. Like this is the
Yeah, kind of a merging of the two.
right. So we need to improve this generic because there are a few things I'm thinking.
I mean,
One,
this generic would be phantom anyway. There is no concrete value of that generic type whatsoever.
right. So what I'm thinking is we might want to do for each field that we add, we're probably going to want to check for collisions with existing fields. So if we took one field in at a time, I'm not 100% sure how to do this with like taking in a variant like a record yet. But if we took in one
With an
field,
intersection and like a check type, which is gonna be never if
right, right. But if we took in like one field at a time, we could like extend a string for the key, and then pass that into the computed field where we check for collisions by putting some generic type here that like is I don't know computed field name.
I don't know if it changes how you do it, because you need anyway to guard on the input. We don't have lower bounds in TypeScript where you can say I want a string which is not something already known. There's no way of doing that through an extends, because it would be the opposite of extends. Would be extended by so
Yeah,
the way of doing like a lower bound would be to have fields to be computed and some kind of check on computed, which check on computed is going to be computed if everything is all right. And
this is what I was thinking, and then maybe we can translate this into this. Um, not a method document for a minute. Where we have the name, the resolver schema extends schema.schema.any.
my point is, how do you ensure that the name?
Yeah, one sec. I'll show you. Um, we would do name. fields, and then something like this. Here, take uh, um, we would need name, we would need fields. Okay, fields. Name extends of fields. Uh, something like error um, field name already exists. Uh, and then this is probably very wrong. So well, at least at this point, if we just return any here for a sec, at this point,
You might want to remove the other function, otherwise you have a completion error. It's gonna be all any's.
uh, um, and then you like obviously we haven't we have not augmented the type of document yet with the computed field, but if we did it like one at a time like this, we could potentially like we have to track it separately probably, but um,
No, we
we could
don't.
transform the computed field into like a schema struct, like basically like the output type looks something like this: document fields and um, name. I know this is not valid. Hang on.
You have to say name in name.
Let's just keep any here for a sec because I don't know if we're gonna need that second area yet.
Just remove the second parameter for now. If it's not needed, it's not needed.
Mhm. Oops. Oh,
Hmm.
and then let's try it again. And this should give us a, oops. See? Yeah. So this is kind of
Yeah,
what I
but
had in mind.
the same trick can be done with a record. You just need to check on the keys
All right.
instead
Help me.
of this on the single name, and you need to, like, at the moment you've defined, if you hover on the computed fields type definition, computed field type definition, it's down. Here you have the computed field name, which is where you do this checking.
Right.
Instead of doing it at this level, you have to do it at the very top level where you are taking the computed. So
Here.
here you would have computed and check, or simply like computed fields of computed.
Okay. Hang on.
Just write a type definition for a moment,
Yeah.
somewhere else,
Okay.
that should take two arguments:
Okay.
the computed, which extends a record of string any,
Record string any.
and the current fields. So
Okay.
yeah, and here you can quite literally say like key of computed extends key of existing fields. You might need to do some distribution. So you probably, this needs to be like more refined.
Mm-hmm.
But the idea would be that the idea would be that here you do the check. Now where the error is shown might be as slightly, like it might show at the top level instead of on the specific key. I don't know if there's a way of doing it on the specific key,
Right.
but I'd have to fiddle with this type. It's impossible to just spell the type out
No, that's fine.
correctly to you out of.
Let's go with it for a minute. So
Yeah, this is not distributive, so this wouldn't work. To make it distributive, you need to add another generic to the exclude duplicated fields. No, at the end, and say like new keys equal key of computed, so that now you can say new keys extends key of existing fields. These would distribute over the new keys because it's a conditional type over a naked generic.
right, and then maybe we can just do like duplicate key for now.
Duplicate key or
So let me do.
computed. Yeah.
Let's separate these out so we can see a little better. Fields. Okay, and then we can. Damn it. Oh well, that was dumb. Ah, right on the key, which is
Well,
nice.
probably because you only have one.
All right, let's find out.
Yeah,
Hmm.
this no longer works. You can do it with a single type. I'll fix it. Mm,
Okay,
I can't spell out the type.
that's okay. Yeah, I mean, we will iteratively add to this. But anyways, the idea being that like if we comment this back out, oops, and we put this back in for the moment. Why do I keep doing that? The idea of here being that like as you iteratively add fields, like you would um, be able to add computed fields, you can compute the type, and you'd get errors that make sense when you end up with a duplicate key, and that the final type is something that's inspectable for the user. Now, I'm going to leave this like this for now, and I'll comment out this one because I also have an idea here. So if we, I think this will be probably maybe the last thing we do today, but meta for now, if we just make this a thing, um, I have an idea here. So something else that you might want to like see when you hover a document is maybe like the source that it's coming from, right? So like maybe as a second type argument here, like seeing that this is like a file system source or something like that might be helpful. So we could do, sorry, of I don't know. Right, so we have a file system source. Um, let me think about this for a sec. So yeah, source. So then we need to take the source and the proto, which we can always move the method around later. But
It's probably safe to also make that invariant for the moment.
oops. Okay, and then here. So now when you hover this, you'll see the document source, and when we add a computed field, if we also take in the source, uh, just trying to find all my errors. Okay, so now when you hover the type, you get the source, and you also get fully typed fields. Shoot. Mm, where did I go wrong? What if? Add computed field. Add computed field. Hmm.
Is meta unused?
It's un. It's like unused currently, but I'm getting
No, I mean
unknown.
if it's unused in the type, it's gonna be unknown.
Oh, right. Let's quickly just.
Which is why I always use the variance thing.
Yeah,
So
yeah, let's just source type ID equals no symbol dot for effect content document source. Hey, um, so now like again, the idea here being that you have access to the existing fields on the document to compute whatever you want, and you also have access to the like meta information that the document source gives you, in case you want to like do stuff with like I don't know the path that the this that when this document gets resolved against a file, you'll have access to like the path, you'll have access to whatever other information the system source like gives you. Um, but yeah, I feel like this is already a pretty good start. This is already like looking like at least from a user experience perspective, when you're defining a document type in your content layer config, this is already the information that I think would be really useful to be able to see on hover, right? The metadata that you'll be working with when the document's actually generated and the source that this document's coming from. Because like ultimately what a user is going to do is export this right from their content layer config, and then the engine would pick this up and would do whatever it needs to do to generate the documents. But
And we could also think about a class-based API so that the type is opaque
yeah, yeah, that would
instead
be
of
really interesting.
being explicit, because otherwise those types will
Yeah, they'll
probably
get.
grow quite large.
But I think like if we do a class-based API, it would still be nice for the user to be able to access like this information at some
Yeah,
um
but it would be something
like
a
post
type under,
something like that.
yeah, something along those lines.
Like what we're doing in schema basically.
Precisely. But anyway, that's API optimization. It's
For, for sure.
beyond this stage.
Well, let me go ahead and at least push what we've got so far. Um, git commit initial document definition.
This seems like my first commit on effect. Initial
Initial with example. um,
for the listeners that don't know, my first commit ever pushed on the effect repository was called initial with example, because I was only targeting my team. I couldn't care less about commit messages.
now I know like for the people that were watching today, like we spent a lot of time just doing like obviously API design, API refinement, etc. I hope that that was like kind of useful. But I know for a fact that like as we get into the whole like engine piece of this and like designing around um like how the documents are actually going to be imported into the engine, and there's going to be things like file watching and reloading and et cetera, et cetera, et cetera. There's going to be tons of good like effects stuff that comes out of this. I think that it's important though, like you know I think everybody who works on the effect libraries is really concerned with user experience and like API user experience. So that's why we try to like focus on making the experience that we give to users when they use one of our libraries good. So we try to spend this time. So again, we thought it'd be fun for folks to see kind of like our thought process in a very unscripted fashion. um, we may do some work on this like offline, but whenever we start a new stream, we'll always like update you folks on any changes that were made, and we'll try not to do anything major without streaming it.
Yeah,
So
I'll try to do the type to add more fields at the same time, which still shows an error. But if I get to do that next time, we can speak about the details of the how.
cool.
Because
Um,
a stream where I'm like 45 minutes like this on the screen thinking, it would probably not be fun to watch.
yeah, I think that nobody's going to be interested in watching that. So
Get.
um, cool. Well, thanks
Well,
everybody for watching.
thanks everybody. Thanks Maxwell for this fantastic stream. Cheers, folks.